Hello everyone, my name is Pulakumar Das. I'm a founding engineer from IMESH. So today we'll be looking at rate limiting using Istio. I'll try to keep it as simple as possible. I am not sure if you have covered the concept of an Envoy filter before. So let's see what we can cover today. If there are any questions anytime, you can drop them in the group chat. Or if there are any sort of like technical issues that you might be facing, if you're not sure that if it is on your end or on our end, you can also put that in the chat. So let's begin. Okay. So for today, we'll just cover the basics of rate limiting itself. We'll talk about what it is, what all we can do with it. Then we'll talk about the EnvoyFilter CRD and how to implement rate limiting using the EnvoyFilter CRD. I'll give one example with that. We'll then talk about the two different types of rate limiting that is possible with Istio. And finally, there will be a demo. We'll showcase one of the most common use cases for rate limiting, which is you want to rate limit like a particular path with for each and every different IP address that comes by, right? For the Ingress side of things. So let's start let's go over what rate limiting is all about. So it's simply a mechanism to prevent your services from being overwhelmed with requests. So this might even happen. This might not even be a malicious thing. Let's say you have provided some sort of an API publicly, and some open source developer or any random user is trying to use that API, right? They might not realize it, but their application that they're building, it might send out a Lotus request, which you don't really want to deal with, right? So even that would count as a DDoS. It would be a very unintentional, non-malicious DDoS, but it would still be one, right? And of course, there is the usual malicious type as well. So you might want to protect against that. Secondly, you might want to protect against cascading failures. So you really don't want your login service itself to fail. If that fails, then all of a sudden your other applications will just stop working right away. And so you would want to protect against that in some way or form, right? We're not talking about the bugs itself. We're talking about if there is a bug-free service, how do we prevent it from being overloaded with requests? And since we're talking about this in a Kubernetes in a cloud-native world, how do we prevent the pod from going down itself? And finally, again, this is the age of the cloud native, and we are also in the age of AI and blockchain and other, very costly resources being used. In such scenarios, again, if you have some API that is making some pretty complicated or some very costly computation, you might want to save those resources. So all of that can be done with rate limiting, and you will be able to protect your services with that. Okay. So how does it work basically? So you have in your cluster, you basically have your rate limiter set to some specific amount. So you'll say that I want this particular service. So in this case, the payment service, to be able to receive around 10 requests per minute. Once it crosses 10 requests in a particular minute, the 11th request that is coming in from any client, that will get rejected. Right? And it will return some sort of bad request. It can return any amount of any specific code that you want to give it. You can also pass in additional headers. You can say that, hey, wait for 10 more minutes before you can access this service again. So this is the sort of the general overview over how the rate limiting works. So now we'll move on to the Istio side of things. So how do you implement using the EnvoyFilter CRD? So unfortunately, Istio itself does not provide you a simple way to configure rate limiting from the existing Istio CRDs. So you cannot use your virtual services or destination rules to configure the rate limiter. Instead, we'll use an EnvoyFilter CRD. So we'll modify the Envoy configuration in the Istio proxy, and we'll configure the rate limiting there itself. Now, one common sort of setup you want to keep in mind is that it implements the token bucket rate limiting algorithm. So basically, you can think of it as there is a bucket with n number of tokens. And so in this case, there are 5 tokens maximum that the bucket can hold. Every time a request comes through, it will take one token from the token bucket, right? And so you can keep on sending requests, and once all the tokens are gone, you can no longer take a token from the bucket. So the rate limiter will instead reject the request. You can also configure it. So after some certain amount of time, some more tokens will be added back. Here we have set it that every minute, 3 more tokens will be added in. So this is the sort of the general logic behind the rate limiting algorithm that we'll follow. And now we'll come to the CRD itself. So again, as I mentioned, this might take a while, and there are a couple of concepts we have to go through here. So the EnvoyFilter CRD, you have to keep a couple of things in mind. I have split it into 3 different pages because this one is kind of big. But first of all, where you apply it and what workload selector you put in it matters quite a lot. So in this case, you can see I've not put any specific namespace, and I've given the workload selector, which its app is HTTP bin. So let's say I apply this, it will get applied to the default namespace, and it will look for the app HTTP bin label. If there is a workload having it, then this EnvoyFilter, whatever config patches are listed here, those changes will occur in the Istio proxy of HTTP bin of whatever workload is selected here, right? Now let's say that I have not given the namespace here, and I remove the workload selector. Now what will happen? Every application in the default namespace, which is wherever this app got applied to, will receive the config patches that I have mentioned now below. And finally, if you want to set the EnvoyFilter to act on each and every Istio enabled pod, you would not have any workload selector, and in the namespace you would set it to Istio system, and that way you can target each and every pod in the entire cluster. So moving on. So config patches. So there will be 2 config patches. We'll talk about the first one here, the main one, which is the rate limiting filter itself. So the way this works, so each config patch, will apply to a specific object in the EnvoyFilter config. In this case, we are applying a config patch to the HTTP filters, and the first thing we want to know is where to apply it, right? Now, again, I cannot go into the details about how the Envoy configuration is like working underneath the hood, but basically there are a lot of listeners created for each of the different ports and all that, and each of the listeners will have a list of filter chains. And one of the main filter chains is this one, the HTTP connection manager, which does all of the routing, and all of the behavior that you expect from Istio is usually performed in the filter chain that contains this filter. So what we are doing, we are selecting the filter that contains this HTTP connection manager name. And just before that, we are inserting our own filter, and we are giving it the name of HTTP local rate limit. And this type config, what you can think of it as, whatever the type URL is here, that is the type of the value that is provided here. So this thing is the configuration for the like the extension or filter that we're putting in, which is this one. And if you want to figure out what sort of options you have got to configure the filter, you can search for this filter directly. Google will usually take you to the latest versions of the Envoy doc. You want to be careful about the version of Envoy that you're using. So Istio is always like a couple of versions behind whatever Envoy is at. So there might be like a field or two that they have described that is not present in Istio currently. So you will not be able to use that. Anyways, so the main things here, you can ignore a lot of the stat prefix here. That is for the metric side of things. So the main thing here is the token bucket. Again, as you can see, just like in the picture here we are set it to 5 with 3 tokens every 60 seconds. Here we have it at 10 tokens maximum with 5 tokens per fill, and every 60 seconds, 5 more will get added. Now filter enabled and filter enforced. Basically, this is saying, again, if you look at the documentation for the local rate limit, this particular type here, it would explain that. So the filter enabled is basically like for how many requests you want to enable the filter, and the enforced one is for how many of those enabled requests you want to enforce the filter for. So in this case, we have sent it to 100 out of 100 in both cases. So all the requests coming in, they will be enabled for rate limiting, and rate limiting will also be enforced on all of them. Now, what happens if the rate limiting happens? So in case the token bucket is finished and the next request comes in, we have 2 different things added in here. So one is the response address to add. So if whether or not this exists, if it exists, then it will get appended, or it will add this header. So the header is extra limited, and the value will be too many requests. And we have also said that the status code will be a bad request here. So again, you'll have to look at the documentation, and there you'll be able to figure out what else you can put in here. Now, so one thing to note here, we are selecting the sidecar as inbound, the contextual sidecar inbound. So what that means is for each and every listener that is inbound to the particular service, we will be applying this rate limiting filter. In other words, every request that is coming through will get rate limited. Now you can sort of get around that by using the concept of descriptors and actions, rate limit actions. So first, so this descriptors, this will come under here actually. And this is a completely different config patch that we are applying like this. So we'll cover this one first because this one comes first, and then we can talk about this. So what this config patch is doing is whenever so Istio by default, what it will do, it will try to look for all the various pods and services that are in your cluster, and it will create routes and virtual hosts for them. Right? It will already do the pre-setup for that. And so what we are doing, we're finding the route which has a virtual host of inbound HTTP 8000, because if you look at the app I'm targeting, it is HTTP pin. By default, the port is 8000 for that. So we're targeting the HTTP requests on port 8000, whatever is coming inbound. And again, the context is set to certain inbound here. So we are taking this virtual host configuration and we are merging in some additional values here. And what we're doing, we're setting these rate limits. And the rate limits here, this is a list of actions. And might be a bit tricky to say here, but it's like, so each of these is an action, and each of this is a set of actions, or rather you can say an array of actions, right? And you can have multiple arrays of actions. So you can have multiple actions, you can have another actions here, and again, you can have request headers here if you like. But we are not covering the multiple action setup here now. But basically this is saying, so there is one actions array here, or one actions vector. And within that, there is only one single action, which is request headers. Now within request headers, there are we are saying that the header name is X rate limit. So if this particular header exists in the request, then it will pull out the value. So whatever the value is set to for X rate limit, it will take that and it will put it in this descriptor key, which is header rate limit. And now a descriptor is, you can think of it like a variable in a traditional programming language sense. And we use that up here in the descriptor entries here. So as part of this HTTP filter here, we are saying that if the header rate limit entry is well present and the value is set to true, so if the request has the X rate limit header and the value is true, only then you give it a special token bucket of 2 tokens maximum and 1 token per 60 seconds, right? And again, so keep in mind that there might be version differences with the documentation you see. So the behavior might be different from version to version because this one in particular is being worked on currently. So currently, I believe if you use up this particular token bucket, it will also use up the token bucket from here in the global one. And you might not have any way to configure that. But anyways, we'll come to that as well. Okay. So any questions till now? I think that covered the vast majority of the confusing stuff. Okay, I think we'll continue. So now we'll cover the rate limiting types in Istio. So first of all is the local rate limiting, which is the very one that I showed over here, right? So rate limiting will happen on a per pod or proxy basis. And again, you should keep the type in mind. So this is a local rate limit. This is the type of the local rate limit filter. And so what is happening is when the request is sent from the client, the proxy is receiving it, and here the rate limiting logic is being applied, right? So it is looking at the request, it is generating the descriptors. So the descriptor is being generated at the virtual host side, and we are also using the descriptors here to look at to figure out whether or not the request should be rate limited. Right. So all of that logic takes place inside the proxy itself, and only then it will be sent to the payment service, and then it will return, or it will be returned straight from the Envoy gateway itself, Envoy proxy itself. Now keep in mind, I have mentioned that it is from a per pod or per Envoy proxy basis. So if there are multiple replicas of a particular service, you will end up with each pod having the same configuration. So each and every pod will have this rate limit configuration. So each and every pod will have a 10 requests per minute sort of configuration, right? So when you're trying to talk to the service, depending upon how your load balancing is set up, you might not get 10 requests per second. It might go to n times 10 requests per second, requests per minute, sorry. So keep in mind that this is for the local one is per pod and not per service. Next, we'll talk about the global rate limiting. So if you do not want the rate limiting to happen at the per pod level, then what we'll do, we'll introduce a secondary service, a rate limiter service, and now the Envoy will send the descriptors to the rate limiter service. This rate limiter service, it will keep track of everything. So it will keep track of how many requests have been used up. Here Redis is shown. I'll come to that again. But so this is going to decide whether or not the request is allowed to pass through or not. If it is allowed to pass through, it will come back to the Envoy proxy and it will continue the request. Now, so the way this is implemented in Envoy itself is that there is a specific API that you can implement as well. But Envoy themselves have provided a sample implementation of it, which is the rate limiter service. You will find it as part of your Istio directory as well if you have downloaded the project. And so that one will use Redis as the backend or for caching. Again, if you implement your own, you can avoid having Redis, or you can put it in your in-memory database. You can put it in MySQL if you really wanted to. You can do whatever you like. And again, we are working with gRPC calls here. So yeah, so what should we use basically, right? What's the difference here? So first of all, the local one, it is very handy to reduce the load at a per pod or per proxy level. It is also cheaper because again, you're not making a request to some other service in your cluster, right? But there is some major limitations right now, at least in the current version of the local rate limiter. So if you want to do on a per client IP based, the global one is going to come in handy. If you want to do it on a wildcard basis, the global one is also going to come in handy. So if you want to do like a /API/star, for example, so each and every path under your /API will get a separate token bucket. That will be possible with the global. And for the client IP one, so both of these fall into the same category. Essentially, the local one, you have to specify a specific value for the descriptor. So when you come here, you have to give a key and you have to give a value. So if you want to do it for an IP address, you can do that here as well, right? You can put remote address here and you will get the remote address as your descriptor entry here. But the issue is you'll have to put a very specific value for what the remote address is going to be. Only then you can set the token bucket for that IP address. You cannot make it so that for each and every IP address, there will be a separate token bucket. Right? And the same issue falls into the wildcard basis one, because you can say that for this specific path for /API/users, you can give it a token bucket. But let's say new API gets added, so /API/accounts. Now that one will no longer be falling into this token bucket here. Whatever you have defined here, it will fall into this one instead. And with the global one, you can simply put /API/star, and each and every path under /API will get its own token bucket. So yeah, let's move on to the demo right now. And again, I'll show the most common use case, which is for rate limiting per IP at the Ingress side of things. Let me begin the configuration. This is a bit too big. Yeah. So there's a couple of files here, but first let me do the pre-setup. So again, I'll use HTTP pin because it is easy to showcase. So we'll install it. Samples HTTP pin and HTTP pin.yaml. I'll deploy it into the default one, default namespace, because I remember correctly that the default namespace is already labeled as Istio enabled. Istio injection is already enabled. So if I do kubectl look at pods, I should see 2 containers. Yeah, 2 containers are running. Okay, so first we want to create the gateway. So I have installed 1.16.7. So let me just create the gateway first. So you need to create I'm using the Istio gateway instead of the gateway API from Kubernetes. And this is just a simple one. Again, I put it in default. So if you're following along, make sure that the namespace is correct. So let me just apply this. Now let's see your system. Okay, let me verify that I'm actually able to hit the service. So we can go and /get. Yeah, so I'm getting a response from HTTP bin. If I do slash, which is the default one, I can show that over here, I think. Yeah, so this is the HTTP bin running inside the cluster. Okay, so we'll be testing with the slash get one, so that it is easier to showcase with curl. And let me create the terminal again. I'll not make this request right now. Okay, now this is done. So we have the Ingress setup. Now for the rate limiting itself, we'll be using the global one because I want to show a couple of things. First of all, the rate limiting config, right? So when you're deploying the pod that is with Istio, let me open that. Rate limit. Okay, so the way this is set up, it will try to mount a config map. And if we do not have this config map set up already, it will cause some issues. So first of all, let me just create it, and then I'll go over what the exact configuration is about. Keep it here. Now keep in mind, so I'll put the rate limiter in the Istio system namespace itself, so it is easier to manage. But yeah, you should keep the namespaces in track here. So put it in Istio system. And now I can apply rate limiting service. Okay. Now this config map, this is handling the second part of the like the descriptor side of things that I was showing here. If you come back to the local rate limit one. So that config map is basically handling this part of the configuration. So it is just handling the rate limiting configuration itself. So let me close this. Yeah. So what it is saying, so you're going to create, I'm creating a domain. So a domain is just a name basically, which you're using to match. So I'm calling it HTTP bin rate limit. And for HTTP bin rate limit, we'll be able to select which domain we want to rate limit against. So for this one, we're saying that there are, so we'll take two descriptors. One is the remote address. And again, I'm not setting a value here for remote address. So each and every value that comes in as remote address will get a separate rate limit token, token bucket. And within remote address, I put descriptors again. So the way this works on the same level. So if I take this remote address and I put it down here again, the same level again, and I put a rate limit bucket here. This would not be a great idea. You should ideally use very different configurations, not the same remote address in both of them. But basically, this is OR, and once you go inside, once you start nesting it, it becomes an AND. So what we're saying is, if there is a remote address descriptor and there is a path descriptor that has the value slash get, or there is a path descriptor that has the value slash, then set this rate limit or set this rate limit, right? We can also remove one of them for demo purposes, but yeah, it's fine for now. Now that this is done, this is the service. Now we'll apply the actual Envoy filter itself. So previously I had shown the local rate limit one. This is the global one. So this is the type of the global rate limit filter. Again, I've set the domain here. I've set the full remote deny. So you can look up what this does. There is a timeout for the service in case the rate limit service does not reply. I have configured the rate limit service as a gRPC service, and it is using the gRPC client. Again, you can look at the configuration for this, and this would all be pretty obvious. So cluster name. So again, you have to give the namespace here and here. Keep that in mind. And this transport API version. This is for the rate limit service API version, basically. Right. So this is the first part. So we are not configuring anything to do with the rate limiting, like token bucket and all at the Envoy filter side anymore. In the global one, we'll do it at the config map side. And of course, if you're implementing your own service, you can configure it the way you want, right? Now moving on, there is a virtual host configuration again. So we're taking any of the sidecar inbound vhosts or virtual hosts, and inside them we are putting in the path. So we are creating a single access vector. Within that single access vector, there will be a remote address. We are not passing any configuration here; it is not required. And there will also be a request address, which is so the colon path. So this is a pseudo header that Envoy will generate for you, and it will take the value of the colon path, which is basically just the path that your application is being accessed on, and it will put it in the path descriptor key. And this one, this descriptor is being used over here, right? And this remote address is from here. So apply this now. Let me check if this one is, no, there is no namespace. Okay. Now, if you want to see this in action, the best way would be to have two terminals side by side. Let me increase the font size a bit. I think 16 is fine. So first of all, we want to see the logs of the rate limit service. So this is one of the best benefits of using the global rate limit service. So the sample rate limiter already gives pretty great logs for us. So we can do logs.sf, and we want app is rate limit in Istio system. Okay, we're getting the logs. Now, whenever you make a request and it hits the rate limiting service, you'll be able to see exactly what descriptors are coming in. Let me create a new window. Okay. Now, what was the IP address again? Get SVC system. Now you can do curl/get. Yeah, and you can see as soon as I made the request, let me freeze this. So it started, it got the descriptors. So remote address is 10.244.1.1. So that is the IP address it received. And the path was /get because I'm calling /get here. You can see it started to get the limit lookup. It looked up the remote address first. So again, this is something I should probably explain before I go in too much. So whatever order you define stuff in is very important in the Envoy side of things. So since the first vector array will first have the remote address and then the request address, you want to define your config map in the same way. So the first descriptor should be remote address, and then the path will come in, right? So it is looking up the remote address, and then it is iterating to the next level. It is going to path introducing the first entry, which is /get. It is applying the limit, and yeah, so you can see the current cache as well. Now let me just hit it a couple of times. So current cache is 1. So sometimes it might refresh the cache before you can see the rate limit in action. But yeah, you can see now we are not getting anything. If you want to see what happened, you can put -v. And yeah, you can see 429 too many requests, and we're also getting the header set Envoy rate limited. So this is the default behavior. You can configure that as well. So what else should I show here? Okay, yeah. So one thing to note, now that I'm making the request from here, you can see the address that I'm getting is 10.244.1.1. This is not my IP address, right? This is not my public IP address that I'm getting from my ISP. So if you do kubectl get nodes and you do west wide, you'll see that it is part of the internal IP net, right? So the way to get around this, this will depend on your particular, what do you call it, your Ingress gateway. So for the Istio IngressGateway one, there is one configuration that we have to edit, which is in the what do you call it, the service itself. So we can do get SVC in Istio system. So this one we want to configure this one. So we'll say edit SVC in Istio system. If you come down to the spec, there is an external traffic policy. It is set to cluster. Now we'll replace this with local. And now we should be able to get the original IP address that is coming from my ISP, right? So if I do the curl again, Yeah, so now it is receiving 106.203.253.338. So this is my public IP address at the moment. And again, if you want to try, you can also try hitting the same like the call command, and you'll see your IP address over here. Yeah, so now it got rate limited. And if I do slash, so because in the config map slash was configured separately, I'll have a separate rate limit configuration for that. So again, I got the response. I'll apply again. I got the response 3 times, 4 times, 5th time, it got shut down. So yeah, that's it for the rate limiting demo. If you have any questions, you can drop them in the chat. Thank you for viewing this session. This was Bulak Das at IMESH. If you have any questions, you can either drop them in chat, or later on, if you're watching along, you can contact us at contact@imesh.ai. Thank you.